my name is Andy Klein. I work over at Backblaze, right? And one of the things Backblaze does is we do cloud storage and all of those wonderful things, and we'll talk about that in a second. Been there for about 5.5 or 6 years or so. Do all kinds of different things because Backblaze is one of those kind of companies that's still kind of small, so you can get to do that, and which is great. So everything from a little bit of marketing to a little bit of product management to a little bit of writing blog posts on hard drives and so on and so forth. So we're going to talk about hard drives and our experience and what we've done with them over this time. There's other companies out there, little tiny ones like Facebook and Google, who probably have 10x those types of drives, but they're not talking. So we'll gladly share what we got and let you know what's going on. I make no recommendations. We did that once. That hurt. But here's the data. Here's what we have. You'll see it. You can ask questions. Maybe at the end we can get to the questions and things like that. But if something really just catches you funny, let me know, and we'll go from there. A little bit about us. Let's do a little bit about us, Pete. You don't need to do that. Right, a little over 10 years old, Backblaze is. You can see our history there. We're now north of just about 400 petabytes of data that we manage. So it's a fairly good size thing. 2 data centers. Right now, a third one's coming online in a month or so. Shh, don't tell anybody. There'll be a 4th one and a 5th one and so on and so forth. It's so we're pretty good at this. Okay, we're certainly not at the scale of a Microsoft or a Google or Facebook, but that's not too shabby for most folks. And we've had some ups and downs. Some of you may remember the Thailand drive crisis. We went through that whole experience of how hard it was to get drives. You'll see some of that in the data as we start to talk about it. And then we've done really well with these little things. These are storage pods. If you're not familiar with Backblaze, back in 2009, I think it's what it was, this is what we store data on. These things are 45 or 60 drive chassis, 4U chassis. We open sourced the design for these. We said, hey, world, this is how we do it. And we published a parts list, and we gave you a manual, and you could make your own. And we've been doing that ever since, by the way. So as we go through, it's really kind of fun. Everybody thought we were crazy because all of the drives we put in went like this, right? They were vertical instead of horizontal. And everybody said, you can't do that. That's horrible. They're not meant to be that way. So now, the more and more I'm seeing chassis with the drives that go in like this because, quite frankly, it doesn't really matter. I suppose some of you in here could talk about the physics and say explaining the angular and all of that kind of stuff. Doesn't really matter. Not in our business and one extra drive a week going down is not an interesting thing at all for us. Okay, so but that's been a really good model for us. That whole storage pod thing. That's what works. We've improved it over the years. We actually built an architecture around it now called vaults. Vaults are nothing more than a conglomeration of 20 of these things, which basically to the internet looks like one gigantic drive. Okay, so when data comes in, it gets scattered across 20 different pods in a RAID. Using a little Reed-Solomon encoding, we spread it out 17 and 3 and blah blah blah. All right, so we're pretty good at this. Like I said, here's what we currently have, and 350. Right, we actually crossed 400 last week after I turned in the presentation. And you'll say 83,000 drives. Why that's not 100,000? No, it's not. This is in operational today. Okay, over the lifetime of the company, we've had 100,000 drives or so. So today, and you can see the mix. So that's what we're talking about when we talk about the stuff we have in our data center today. And I'll do that back and forth, and I apologize if it's confusing from time to time. This is our current environment. Most of what I'll talk about today is our lifetime environment. So going all back to one. I just wanted you to get a sense of scale and all of those kinds of things. So hard drive failure rates, that's what we kind of know we're known for. We publish quarterly some statistics. Some people like them, a lot of people like them. Other people don't, and such is their right. And we have a good amount of conversation about it, and being in marketing, that's a good thing. There's no such thing as a bad conversation. Right? So the basics. So what do we do? How do we collect the data that we're going to talk about today, right? Very standard set of tools, the SmartMon tool set, right? And once a day, we take a snap of every drive in our data center, all right? And then we record that and we keep it, all right? And that's a lot of data. Now, we can do this. I imagine if somebody like, again, Facebook or Google did this, they would probably need to build an entire data center just to hold the data because they have a fair number of these. But you can see what we do. So, and we started doing this back in April. We actually did it prior to that, but we only kept the data for 30 days and then we got rid of it. And then somebody had a brilliant idea to say, what if we just kept this? What could we learn? All right. So each drive, each day, right, of all of the different drives we have in the data center. And that includes the data that customer data is stored on. It includes boot drives. It includes management systems. It's all of this kind of stuff. Now, we'll talk primarily about the customer data drives, okay, because the other ones are a boot drive for us spins a pod up and then basically goes to sleep for a year and a half until that pod needs to be spun back up again. So not exactly an exciting life for it. Whereas the management systems, they're used differently than the consumer drives. So we'll focus mostly on the customer drives, and that's what it is. So the data, okay? At the end, you'll see a URL where you can actually go and get this data. It's free. You download it, have a good time. Okay? People have done that, and you'll see that in a little bit. You will need some time, because there's a fair amount of it. We divide it up into, we used to do it annually, so you could download all the data for a year. Now we're doing it quarterly, because we're starting to get into nearly a gig a file, and so on. And it looks like this. It's kind of boring, right? And it's that information. And then this starts with the attributes, all of the smart attributes. We record those too, all right? And we keep those too. And we'll talk a little bit later about some of the interesting things we observe with smart stats. So you can see what we have, a serial number and so on, model type, more drives, okay? So in our case, it would be roughly about 85,000 of them today if we took a snap, okay, today's snap. The only thing we add that's not there is that failure column, right? That's ours. What's a failure? Okay, we'll get into that in just a minute, but we record that, and it's 0 or 1, okay? And then the other little thing is once a drive fails, it disappears from the records, okay? So it has a history, but then if this comes up with a 1, then tomorrow this line will not be in the database, okay? That's just the way we do it. So if you're starting to analyze the data, you'll see that. Where did it go, okay? There will be times when you look at the data, and this drive will be there today, and then it won't be there tomorrow. But it didn't fail. Why? Well, we do things like migrations, right? We take drives out of service. We used to use a lot of 1 terabyte, 1 and 2 terabyte drives. We don't have any of those anymore. So the data doesn't show it as a failure, okay? The data just shows it's there, okay? And I'll get into why that's important in a minute when we start to talk about how we compute failure rates and all of those kinds of things. It's not particularly complex, but if you don't know that, and you suddenly say, where did that go? Where did those 45 drives go that were there yesterday? Oh, well, the storage pod that they were in came out of service. They won't stay out of service all day or anything like that, but that's what's going on, okay? Okay, so cumulative from back in April through today, to the end of the month, is the data that I'm working with today, all right, through the end of August. So I didn't quite get to 100,000 drives. I had to make a prediction when I wrote the description for this 4 months ago or whatever it was, and I said, yeah, I know, we can get there, yay, all right? So we're looking at 99,975 drives. So those other 25, I think, will probably teach us something very similar to what the rest of them are, but I apologize for that ahead of time. Over the course of that period of time, that drive collection has had 6,000 failures. So for those of you who've had a couple of drives fail at home and you know everything, okay, we have a few more failures. Drive failure doesn't scare us. It doesn't scare any of the big guys. It's just part of the beast, right? And what you do is you make your software run around it. All right. We use RAID we actually use our own erasure encoding algorithms that we use, and to do that, to work right around it. So a drive failing for us is just a non-event. All right. Drive days. This is important. This is the first real piece when you start to talk about failure that's important. You need to have those two pieces of data. The fact that something failed, and drive days. And what's a drive day? All right. A drive day is, to us, the drive was operational and listed that day. That's 1. And that drive is spinning the next day when we take the thing. That's 2 for that drive. And then you start to add up all of the drives. So every day, for example, in our data center, we have 85,000 drives spinning, and at the end of the day, we add 85,000 to the count of drive days, right? And the reason we do that has to get into how we compute failure, but understand what a drive day is, right? We could look at, there's a smart stat, I want to say it's 9, now I've forgotten. There's a smart stat that records drive hours, all right? The problem with it is, especially when it's starting to fail, sometimes that number gets goofy. And sometimes you get a brand new drive that has hours on it. How did that happen? This is the best number, the best way we can count it. Okay, it doesn't rely on the drive and the information on the drive. It's just, are you here today? Yes, that's a 1. All right. Now, if you just did a little simple math, you go, well, good. Your failure rate, 6,000 failures, almost 100,000 drives. You got a lifetime failure rate of 6%, right? That's really nice. Except it's not quite a useless number, but to us it's not particularly interesting because it's basically for those 2 numbers, and it applies nowhere else. What we do is we compute this thing called an annual failure rate. Okay, so an annualized failure rate, to be more precise. And that's the formula down there. And it's very simple, right? But this is the number of drive failures you can see divided by, there's that drive days. How many operational days was that drive, that group looking at, divided by 365 and so on to get your percentage. The annual failure rate of all of those drives, that 99,000 plus drives, over the course of that 4 or 5 years, the annualized failure rate is about 3% in our data center, all right? That's for all of the different drives. Now, one of the things we'll do is we'll look at models, different models and so on, as we go along. Yeah, we're doing fine in time. We'll do, but this allows us to do things like compare annualized failure rates for 2 different drive models. This allows us to look at 2 different drive models over different periods of time, right? So I can look at a failure rate, annualized failure rate for a quarter. And we do that. When we publish our data, we publish the quarterly statistics, and then we publish it, say, hey, for this last quarter, here was the annualized failure rate. So it keeps everything the same. So those two numbers are all you really need to compute all of this, okay? To compute these, and it works. And we didn't think this up. We actually went to some really smart guys in the storage business and some statisticians, and they said, this is probably the most straightforward way to do it. And then because it works. Some people have flipped this around, and they like to do life expectancy. And I'm going to get the name wrong. Myers. Yeah, I can't remember what it is. It comes out of biology, and it's how long does a drive last. And we've had a couple of folks do analysis using the data of that. This is the flip side of that. This is kind of like, what's the chance you're going to fail? So, so doing that, we could do things like this, all right? Over the life of all of our drives, here's our just a short table. We've had like 58 different models that we've used, right? And here's my top 5 or how many is there? 7, and I call them the most experienced drives, right? These guys, 31 million, drive days, all right? So that's a fair number of drives spinning away out there, right? And there's the failure, and there's the math, right? So for example, those Seagates, that's a pretty darn good number, right? 2%, a little over 2%, right? Those 4 terabyte ones, they're still, if you remember way back in that Earth slide, right now our data center's full of them. So doing really great, right? You can see some of the others, some of the HGST ones, if they have HD, starting out HD, that's actually Hitachi before they got acquired. And if it's HM, it's the HGST, it's after they were acquired. So that's a good way of telling the difference there, but all of them are really, really well. These, in particular, these 2 terabyte ones are gone. So we've taken all of those out. And these are also gone, and we were like crying. I mean, when you start looking at that number and saying, less than 1% failure rate, and you got to take them out, you just go, right? What can I possibly put in there that's going to get me a number like that? But we needed to do it for what? Density, all right? When I'm running, something like a 2 terabyte drive, and I can drop an 8 in and get 4 times the density, I got to do it. And by the way, they use almost the same amount of power. This one's a little bit piggy, but it's not bad. So this is just the way we look at data, the way we look at analysis and stuff, and the kinds of things you can start looking at with this. Now, one of the questions that comes up is, what's a failure? Hey, you're talking about failure rates. I kind of like to know, right? And so we have 2 very, very solid concrete ones and 1 squishy one, okay? Obviously, if it doesn't spit up or the OS doesn't know what it's there, yeah, okay. If it won't stay synced in a RAID array, or it keeps falling out, or whatever the case may be, that's obvious too. Hey, we can't use it, right? This one has to do with smart stat values and other little things that go bump in the night, right? And we'll talk about smart stat stuff in a few minutes, and the values that we use and the values that we could use, all right? This one is what I call the ops guy's discretion. All right, so you're sitting there, you're an ops guy, and all of a sudden you look at a status of a pod, and you see an FS file system check error come up. Interesting. I wonder if that's something I should pay attention to. So you do a little digging, and you notice that this particular smart stat is starting to go. Is that a bad thing? Okay, and so you can start to do some of the diagnosis on that. Sometimes you get other things that are happening, like let's say a backplane, because we have 5 drives sitting on a backplane that share a backplane, right? And a backplane can sometimes do goofy things, all right, like take out all 5 drives on it, all right? So this is like I said, it's a little squishy. But you could actually use smart stats to get some really interesting information. When a drive comes out and it's failed, we actually run it through a sequence of tests. We run it through a short reformatting test, and then we run it through a test provided by a certain manufacturer who I will not name because they don't want us to, that runs for about 2 hours on a drive and goes through and basically does a whole bunch of writing and all kinds of interesting things and reading from it. If that drive, by the way, passes those tests, we will actually put it back in inventory and use it as a spare. So sometimes something can fail and come back. All right? And you'll go, doesn't that pollute the data? No. All right, here's why. Remember I said when a drive comes out and it fails, it's no longer reporting statistics. So remember, it disappears from that line. So as long as it's sitting there waiting to be a spare, it's not reporting any more data. If it does go back in service, what do we start counting? Drive days, days in service. All right? So it actually keeps the data clean that way. If we were to go back to hours, use that smart stat for hours, we'd actually corrupt the data at that point because you'd have the data twice. Anyway, so this one here is, like I said, is admittedly a little squishy. But something comes out, it fails, it's marked as a failure, and so on. Now, what have we learned over time? Okay, everybody knows what that one on the right is. Right? It's your right? No, it's your left. Right? And you've seen that before. That is standard. That's just this classic bathtub curve. Infant mortality. Okay, a lot of things work this way. Okay, it's just it's a fairly standard model for mechanical things. Drives should probably follow the same one. And if you were to actually look at this, I don't know if you can see those, it's a little fuzzy. Early on, our drives are failing at a fairly high rate, infant mortality. That comes down over time. They settle into a nice area where the failure rate is very low. And then as they start to get some age on them, the failure rate goes back up. It fits the curve. You know, the drives fit it. It fits it very nicely, actually. We've seen some very interesting things lately where infant mortality is getting to be less and less of a problem. So in other words, it's really been quite interesting that newer drives, in particular the bigger ones, the 6s and the 8s, and such, seem to be a little, how do I say this? They're a little better coming out of the factory, so to speak, and they seem to work a little bit better, and they have a lower infant mortality rate. But we don't have enough data on it yet, enough time to see if it changes that much it changes the curve. There's still some there, by the way. You will get failures that happen in the first 30 days, in particular, that are just at a higher rate than a normal run rate. But they all seem to fail. But like I said, as a generalization, they fail early, smooth out, fail late. The model works. It works. It's worked for all of the different models. The only one that was a little interesting, we had some Western Digital green drives, okay, 1 terabyte ones. They were like the first groups that we put in. And those guys were they failed early, and then they hit that number in the middle, and they just ran. And they just ran. We took them out at like 6.5 years. And they were still, their failure rate was the same from like 2.5 to 6 to the end. Right? I mean, they just never went back up. It was quite amazing, actually. We just didn't have a lot of them. Excuse me for popping that. We didn't have a lot of them, so you don't see it much in the data. We only had 500 or 600 of them at the most. They were the only anomaly I've seen out of that so far that hasn't followed that curve. And they just, like I said, they had some infant mortality, and then they kind of leveled out, and they just stayed there. It was interesting. So this is the question that a lot of folks like to ask. If I buy a 4 terabyte drive, which one fails? How does it work? All of these kinds of things, right? You can see the failure rates by drive size. That's what this chart is. We just put 10 terabyte and 12 terabyte drives into service about 2 weeks ago. So we'll start having data on that. So maybe, well, when we do the Q3 numbers, they'll be in the Q3 numbers, but there's no time on these things yet. So everybody will get excited because we're looking at them, but there's nothing to look at. This number here, that 6.68, is the Thailand drive crisis. Absolutely. We had a busload of those. That's right during there is when that happened, where drives started to get really hard to find. The only thing we could get our hands on that anybody was 3 terabyte drives. It was because of all the channels dried up. And the drives, you can make whatever discussion you want. We just didn't have any luck with them, and I'll leave it at that, so I don't go to jail. No. What's that?
Were those the ones when you had to crowdsource drives?
Yes. Yeah. That was an interesting time. It was great. It was a lot of fun. He's pointing, crowdsource is a friendly term. That's a nice term. We called it drive farming. It was hard to get drives out of the normal channels, and people were charging ridiculous sums of money out of the normal channels. So we turned to do consumer stores. We were going to Best Buys and Costco's and so on and so forth, and buying drives and putting them in. But lo and behold, even those weren't as good as they should have been. But you can start to see the numbers there. These 8s are really proving to be quite good. This number 5s, we only have 45 of them, so I wouldn't do anything with that number. That's we bought. I think we bought half the supply at the time of 5 terabyte drives, because you don't see them. You see them every once in a while at a store someplace. I think this is one of those things where they made these thinking, hey, 1, 2, 3, 4, 5 is the next number. And then realized that maybe 5 was a stupid number, and they started making 6s. There's no 7s that I'm aware of, so now they're skipping. Because, what's the difference between 4 and 5? Yes?
Do you have a mix of client hard disk drives, enterprise hard disk drives?
It's a good question. We'll get that in a second. How's that? Okay, we'll talk a little bit about that. Most of these drives are consumer drives. Okay, and if you look at the models, that's what you'll find. They are consumer drives. We have some enterprise drives, and I'll show you those in a second, which is...
Can you comment about your 1.5 terabyte drive? Experience.
No. That was a particular model of a particular manufacturer that we didn't have any success for. Okay, I think the best thing to say is we have a certain environment. Okay, certain drives will work, and this is part of our learning experience too. Certain drives work in that environment, and certain ones don't. And so what you want to do is test that environment before you put them into production. All right, and I think we had a bunch of drives that we bought, that 1.5 terabyte ones, that weren't right for our environment. I think that's a fair statement. And now, I understand that a lot of other people were dissatisfied with 1.5 terabyte drives from certain manufacturers too. Okay, our experience was that they just didn't work right. There was one of the things our drives do is that they're always running. Okay, you're reading once you write on them, and there's always reads going on, because I have data from 1,000 people on a given drive. And so anytime somebody wants to do a restore, you're pulling off a file here and a file there, a file there, right? That's the way we do it. And a lot of those drives like to cycle down, especially early on, and they didn't have that technology nailed very well, especially when they started doing this. And so they would try to take them all the way down, and just as that thing would get down, we'd hit it. And it come back up, right? And it'd spin a little bit, and I'd say, oh, it must be time. And they spin back down, and we hit it again, right? And I don't think that was good for it. I think that's fair. They've gotten better at how to sleep a drive over time, because we have several models now that actually have that in them. And we've gotten better at at how we store data over time. So I think it was just a good solid mismatch, and that's why it is what it is. Okay, so you asked about consumer drives, okay, and enterprise drives. Do we use consumer drives in our data center? Yes, we do. That is what we've been doing since the beginning. All right, why? Because they're less expensive. And if you don't really care about failure, right, in other words, your software works around the failure, why would you pay for enterprise drives? In our particular case. I mean, now, that 1.5 terabyte drive is an interesting story, right? It was a learning experience for us about doing that. The 3 terabyte ones, the drive farming thing, that was a real fun story. But we've always managed to make this work, okay? Now, a while back, maybe, this is probably 3 years ago, 17, yeah, at least 3 years ago, somebody did this analysis. I didn't do it at the time, but somebody in our company looked at this and said, hey, we have some enterprise drives. The trouble with this one was the use cases were different. This was the ones that were the data drives, and these were our management system drives. All right? So they compared them, and everybody went crazy going, oh my gosh, look, the failure rate of enterprise drives is terrible. And even though, one, it's not a lot of data right there, and two, not a lot of failures, all right? And then the use cases were different, all right? So we had this, they published a post on this, and I'll be honest, I didn't particularly care for it, but I don't run the company. But we've gotten a little bit better, to your point, okay? This is a pretty fair comparison at this point. This is 2 different Seagate 8 terabyte ones in the same environment, okay? Enterprise class drive, consumer class drive. By their own admittance, this is Seagate's stuff, right? And you can start to see the numbers there. And you'll go, oh my goodness, enterprise drives fail at a higher rate. That's terrible. Little couple of things to look at when we look at this data, okay? One, where are they in that bathtub curve? Right? And two, where are they in years of service? And so if I take this set of drives and I back it up in the data, I go back in history, because you can do that, and go to approximately these same numbers, okay, in other words, I normalize the two to the same time frame, this becomes 1.6. All right? Now, will it stay that way? Can't tell you, but right now, they're about the same. Now, you'll go, well, that's wow, okay, it's great. Except that this one costs me 2.3 cents a gigabyte, and this one costs me, 2x that. Maybe 4 cents, right? Now, this one has a 2-year warranty. That one has a 5-year warranty, right? And yes, we will return drives, okay? It has to be worth it at some point, okay? If a drive has got a 2-year warranty and it's at 1 year and whatever, yeah. But yes, we will return them. So right now, what we're seeing in our use case, in our environment, right, they perform approximately the same, right? Now, we're able to get drives that are slightly less than you would probably pay for them, because we do buy them in bulk. So for us, there's actually very little price difference. For you buying 1 or 2 off the street, you're going to pay a big difference, okay? And you may like that warranty. And that's because that makes you feel warm and fuzzy. But the failure rates right now are about the same at the same period in time. So over the next year or so, we'll continue to monitor this and continue to report to this number. All right. But I always caution people when they look at a number like that and they go, oh my gosh, no, there's a few things we have to adjust here. Let's normalize them back to the same time period and so on. So. But when we do that, at least the initial indications are the failure rates seem to be about the same right now. I bring this up because everybody makes their own list of what's important to them when they buy drives, right? And we're no different. All right. The most important thing to us is what we pay per terabyte. It's as simple as that. And why? Because our software is built to deal with failure. It's as simple as that. Okay. You may flip this thing. You may want speed. Right? I don't have a speed issue. My drives are spinning at 5,900 RPMs. They're not a bottleneck. You know what the bottleneck is you can't get us data fast enough. Right? At any given time, I have 50 servers sitting out there waiting for data. All right? So you can't get it to us fast enough. Although when CrashPlan gave up on their consumer business this last couple of weeks, we've certainly been tested. Let's just say that we've acquired a few more customers than we normally would have. And our data center guys haven't slept in 2 weeks. So it's been a good 2 weeks, by the way. Yes?
You don't have capacity. Is that linked to power? So buying 8 terabyte versus buying 8?
So that's a good question. Power is our second concern, all right? And the reason has to do with the way we provision things, okay? Right now, we don't build our own data centers. So we have to move into a facility, a co-location facility. We have to provision a certain amount of power per rack. And you have to do that ahead of time, a long time, because the organization, the building, only has so much power. So, for example, if we have a rack and they go, look, you can have 30 amps in that rack, then it's all we get, all right? So we need things that run low. So for example, when 8 terabyte drives first came out, we put them in a rack and we said, no, that's not going to work, because that means a rack that normally would hold 10 storage pods in it can only hold 8. We did all the math and we said, no, that's not good math. I need to maximize that space, that footprint. So power is really important to us. The 10s and 12s, interestingly enough, are coming in at really good power ratios for us. So that's a nice thing. I think right now, like I said, we got them in, we're testing them out. They seem to be doing really well. So we're looking forward to those. Fits our usage. I mentioned that earlier, kind of, hey, what do? We stick a drive into business, and then we write on it. We just pound on it and say, we fill it. We don't quite fill it. It fills to about 95% or so, all right? And then once it's full, it kind of sits there, and we read from it randomly as we need to, all right? That's our usage case. And then every once in a while, we go back and we delete some stuff on there, and then we write some more things on there. The other thing we do on a regular basis is we also go out and we integrity check files. Okay, everything in our data center gets integrity checked once every 30 days or more often if we have the time. So every single file goes out there and says, hey, is this still good? And if it's not, then we rebuild it from the other pieces of the RAID and so on, right? So that little read operation, okay, it takes a little time. So look at it this way. A whole bunch of writing, a whole bunch of reading in little tiny chunks. And occasionally some cleanup work, delete a few files that people don't want anymore, whatever the case may be, write and fill up the spaces, okay? That's not a normal use case. That's not the one you got at home in your laptop, all right? That's our use case. So it has to fit that. Your point about the 1.5 terabyte drives was right there, okay? Failure rates, we care, all right? But the difference to us between a 3% failure rate and a 6% failure rate might mean 2 drives a week. We got data techs running all over the place. Another 2 drives, says the guy who doesn't have to replace them. Doesn't matter, all right? Yeah?
You said that AF4 doesn't matter that much because you have software.
Right.
So why does it show up at all?
Because if it gets too high, it gets to be painful.
What's the number?
So I'm going to say it's like 10, because we've gotten to that point before with some of the drives, all right? But it could just, what you're really looking for is something that's moving up, okay? So as drives get later on in their drive curve and their lifetime and it starts to move up, that's really what you want to pay attention to. If I put a drive in and it's failing at 10% right out of the box, I got to start thinking about whether I want to keep that drive as a model. In other words, something. So we go through a process now where we vet drives as a group. I mentioned earlier the 10s and 12s. They're in testing right now, if you will, but they're actually live. They're in production systems, and we run them in. We fill an entire storage pod with them, like this, and then we run them what's called a tome, which is across all 20 of the systems. So we get to see how they behave with the different loads. And they're both doing quite well, but that's our testing model for us. We used to just put them all in a pod and let it see how it worked and everything like that. Then we'd buy some more and see how it worked. This other means seems to work a whole lot better for us. And so if we see a high failure rate up front, okay. More than likely, what you see is a failure rate over time that starts to bump up. We've seen some drives models literally hit the wall. 2, 3%, 2, 3%, 2, 3%, bang. And they just jump up to 8 or 9% all of a sudden when they get to 3.5 years. All right? So you just have to pay attention to it. What you're really looking for is delta. Warranty, like I said earlier, it's an interesting thing, but the difference between a 2-year warranty and a 1-year warranty and a 3-year warranty. And then finally, for us, it's speed, because like I said, I can't, the drives are fine. They'll take data, we throw it at them, they put it, whether it's 5900 or 7500 or 7200, excuse me, or 15, doesn't matter to us. It doesn't make the process any faster. We did see some of the Seagate 8s came in, the Enterprise 8s, and they're really fast compared to our other stuff. And when we were loading them, they load a little faster than the other ones, but it's just a data load kind of an operation. So I could load them. If it took us normally 60 days to fill a vault, which is 20 of those things altogether, right? It might take us 55 days to fill a vault because those drives work a little faster. Okay, that's cool, but it's in our whole environment. It's not the most important aspect for it. So. All right, so we got a little bit of time, so great. So we'll talk about diagnosing sick drives. Can you actually do this? All right, and so the first thing is we monitor, I mentioned earlier, we monitor 5 stats. Okay, so our guys pay attention to these. 3 of them are Seagate only. The other 2 are for all drives, including Seagate. Okay. We'll talk about some other ones besides this a little bit later, but this is what we monitor, okay? And the reason why was because when we first started out in this business, we talked to different manufacturers, different places, and they said, hey, these are ones that are interesting, okay? So nothing magical there. So do they actually work? Right? So you can look at them, and there's your operational drives that have those errors, okay? And an error to us is a raw value of greater than 0, okay? So 0 is good, greater than 0, okay, is bad, okay, for lack of a better term. And then a failed drive is running at these rates. So you can look at them and go, well, none of them are particularly good at predicting. 40% is not bad, okay? And this one here, that's not bad. That's a really good, false positive kind of a number. This one, command timeout, is an interesting one only because you can have that happen when there's other problems. So I mentioned earlier a backplane going, and the drive is saying, I can't finish. Well, of course you can't finish because the backplane is busted. Okay, you're not getting the full signal and stuff. So sometimes you get some fuzzy things. So when you start to aggregate them, they start to look a little better. All right, operational drives that have one of those 5 attributes, or in the case of Seagate, it's 5. In the case of HGST, it's just 2 of them. All right, you can look at that and say, oh, it's not bad. You got 76% of the time you could kind of feel like you had a good handle on it, right? But this kind of analysis is, I always, the term I heard somebody use once, it's like cutting butter with a chainsaw. You know, you can get through it, okay, and it works, but you got nothing when you're done, right? And so the folks, there's a couple of different places, and I like to go to this one. This is a study done by the folks at IBM using our data, which you are more than capable of using, right? And they studied a particular drive. So they went through and they trained a model up and the whole 9 yards, right? And you can read this. This is a fun paper to read, by the way. And admittingly, you know, and this is what the kinds of things they came out with, right? And they said, look, if you have a smart 197 raw value of greater than or equal to, throw it out. Just throw it out. Start all over again, because there's a 100% chance that thing's going to fail. All right? So they started to do this. All right? It's a really nice paper. Now, one of the things they did, it goes through 2015's data. So one of the things we want to do at some point is test it and see how it's held up over time. So pretty cool. They also did it for the HGST model. This is unfortunately a 2 terabyte model, so it's not trained up anymore. But the idea here is that using the data that we had, they could go through and create a model that allowed you to figure out whether or not you could have a healthy drive or whether you should be replacing a drive. So it was a lot of fun. It's a great paper, by the way. It's there. It's on the bottom. You all get this deck anyway, so you'll have reference to that if you want to go read it. And then one of the more fun things they did, which I thought was really great, is they went back in time. And they said, well, I can predict at 98% accuracy, right, a day out. That's not bad. Even a day is good. But could I do it 30 days out? So you start to think about what that means in a data center. So you start to see these numbers, and you go, about a 75% accuracy. Maybe it gives you something to keep an eye on. Is it continuing to do what it's doing? Because one of the things you'll find out we know about drives, is that they seem to go too fast. If something starts to look a little funky, right? Sometimes they correct. The Seagates are particularly good at that, by the way. They seem to be very, very good at something's a little squirrely, and then they kind of, I don't want to say repair themselves, but they figure out a way around it and they keep moving forward. And whereas our HGST drives in particular, when something started to get a little squirrely, those things would go south. They just go. And I think it's just the way that they're manufactured. A couple of.
I noticed Western Digital is conspicuously missing.
Yeah, we don't have a lot of them. We again, that first value thing, the price. Okay, we just can't get a good number from them on price. It's as simple as that. I'd love to have more of them. Not for this purposes. I just would like to have more Western Digital drives in there in general, because it's good to have different manufacturers in. All right, so I got to wrap this up here real quick. A couple of others that were interesting. High fly rights, which is a 189. This one is a good exercise in that you can't look at it at any given moment in time. You have to look at it over a period of time. All right, so we've seen drives if you saw a drive with 131 errors, okay, in there, you go, oh my goodness, that's a really big number. Except a couple of things you have to know. One, that number never goes down. So it gets an error, and then it gets another one, and it becomes 2, and it gets another one, it becomes 3. That number never goes down. And you're going to have these happen from time to time. And if that 130 times happens over 2 years, that's like one a day, or one a week, or whatever, one a week, right? And that's not a problem. But you have 130 errors in a day, and that's a real problem. So you have to. This one needs a little more study, because one of the things we weren't set up to do was deal with this notion of frequency, of how often something happens. So it became an observable one. I actually think it could be a pretty good one, but so far it hasn't proven to be. We haven't been able to get it out. Spin-Retry, this is I turn on a drive, and how many times does it take before it comes up, right? We don't turn on drives very often. I mean, we turn them on, and they're on, all right? So we don't recycle. All right, so I think it's actually a really good one for a home computer user or somebody like that who turns off their machine on and off all of the time, but we don't recycle this. This is a decent one. And then, of course, that begs this question, which is, should I turn drives off? Or should I turn my computer off at the end of the day, or should I just leave it running, right? My favorite question. And no matter, we could take a poll in this room, and it'd be 50-50, all right? And just so you know, this is what we found. So you can make up whatever story you need to support your argument. But when drives failed, they were turned off and on more often than the drives that didn't fail. Okay? I don't know if you can tell your mom not to turn off the computer at the end of the day because she's saving a tenth of a watt of electricity, but that's the case. Anyway, we're right up against the time here, so I want to make sure you have it. So if there's a quick question anybody has, otherwise I'll be here. I'll be out in the hallway for the next little bit. Because I want to make sure you get to your next session, have enough time to grab a cup of coffee. So thank you.